Hi everyone, in this video we're going to take a look at a Junior 5 question from 2010 CCC competition called Night Hop. Personally, I think this question is very significant to learn a technique called BFS. So yeah, so I'm gonna read the problem and discuss this with you. Below is a times a chessboard on which we will disgustinate square locations using order pair as indicated. For example, notice that piece A is at a position 2-2 and piece B is at position 4-3. A knight is a special game piece that can leap over other pieces, moving in L pattern. So L pattern, this is L, this one is L, this one is L. We can see it. Let's continue. Specifically, in the diagram below, K represents the knight starting position, and the number from A through A represents possible places the knight can move to. The program will read the starting position of the knight and output the smallest number of jumps or moves to need to arrive at a location specified okay, in the second input. So yeah, so you can read this input. The input will be two lines. Each line have two numbers. The first one is the x value and the second one is y value. First line is the starting position, and the second one is the ending position or destination. It's so ugly, my handwriting. But never mind. Let's put these boring numbers in the chessboard. So 2133, 2133, and what we need to figure out is the minimum number to get to that place. Okay, so once you notice this problem is asking you to find the smallest number, the first thing you need to come up to your mind is BFS, which I mentioned over there. What is BFS? It is a certain technique that you just go through level by level. For example, you have a starting root, maybe some of here. This will lead to plenty of them. I hope you get the idea, and I'm gonna do a quick explanation of BFS and DFS. DFS is you go there, go that. Sorry, I use a different color. Nobody can see this. So DFS is just go with steps. So you go to Z, and then go to Z. Yeah, something like that. It's just like it's not about how wide you go, it's about how deep you go. But BFS, what we are using here is how wide you go. So if your result is actually here, this is your destination, you don't need to find that many, and finally travel to that the destination. You can just directly, not directly, when you explore level by level, it's gonna appear on your first level, so it's faster when you are trying to figure out the smallest jumps. Yeah, so not smallest jump, it's just like smallest value in general. In this case, it's jump, and here it's a chessboard instead of a tree, but we can treat it as a tree. For example, this is starting position, and this level are the moves the starting position can make from the starting position, and those moves can move to other places and maybe involve them. That's where the destination is. So in this case, the smallest move is just one. You can travel from there to there, there to there. So just one. And as long as never mind, nothing. Let's go to the IDE and let me explain this with code. Okay, welcome back. So code is in C++, which is a cool language. Uh, it's pretty similar to Java, and you can just treat vector as a realist if you find trouble to understand it. So I hope you can maybe code your own solution in your preferred language, maybe on your own. But today here I'm gonna use C++ to explain. And what matters is not the code, it's the ideas behind the code. Okay, let's begin. I created a class called positions. It just I didn't know a thing called pairs at that time, so I just used position, which can totally be replaced as pairs. Create a boolean thing called visited, so I can track down my visited places, visited positions, so I don't have to go there again, which is gonna put me in an endless loop, possibly. So here I'm just taking out the inputs. I created two vector, or in Java it's probably a realist called BFS, and a vector called new node. So remember, we are trying to explore each level at a time. So our current level, we're gonna use BFS to record, and the new level, we're gonna use new nodes to record, so we won't lose track of them. So when we are at a level, we can just put things in the new node when we find possible position to go. We're gonna add the starting position to the BFS vector. Visited starting position equals to true. It means we have been there. We don't have to go there again. Doesn't make any sense to revisit a place. It's not make it shorter. Create an variable called counter. Counter starts from 0, and while bfs.size is bigger than 0, it means there are still possible position we can travel to. We're gonna clear up the new node vector, so there won't be any leftover nodes from last iteration. We're gonna go through each BFS nodes, and if that node is, or if that position is equals to the final position, it means yeah, we reached that destination, and we just need to output the counter, which is the level, the number of levels. So here is 1, here is 2, here is 3. If our destination is found here, let's call it dest. So we're just gonna output the level number of that position, which is 2. Actually, we are recording the moves, so this should be 0 because you don't need to make any move, and it should be 1. So we're just gonna output 1. It's on the second level, but it is the first step. It's gonna take you a step. So if it isn't the destination, we're gonna use that move to figure out where can be moved from that move. It sounds confusing. Where can be moved from that position? So we're gonna create two variables to record the xy coordinates, because this one is way too long, and this one just save us some time to type. I use this if statement to verify if it's still on the board. If it's on the board and it haven't been visited, then I'm gonna set it to visited and push it to a new node. That's the next level I'm gonna visit. So I'm gonna repeat the same process for 8 times, which represents 8 possible moves I can make. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. After I repeat 8 times, I'm gonna set BFS to new node. It is like me stepping up to a new level, like my BFS, and counter plus plus. It's just me to just ascend into a new level. And technically, we will find the destination through the iteration, because you can just visit any point on the chessboard with knight if you have some chess knowledge. So you can also add something to print at the end if you are not certain about that. But I didn't, so I hope I got it right. Let's try to run the sample input. The sample is, never mind, let's just save some time and try to run in a DMOJ. And as you can see, also test cases passes correct answers, which is happy. And we go back here, I want to do some final conclusion. So for this question, I really want you to learn, I hope you to learn the BFS, the technique of BFS, and maybe when to use BFS. And other than that, this question isn't complicated because every position supposed to have like 8 children nodes. Yeah, and once you do some work, do a lot of work, to repetitive work, usually we'll just get the result. And all in all, this question isn't hard, but I want to convey you the idea of BFS through this um, video about this question. Okay, I hope you learned something from this video. Okay, I guess I don't have anything else to add. Really hope you have learned something from this video. Uh, Maybe you should try to code the solution in your preferred language like Python or Java. It just make your uh, knowledge more rigid and understanding better or stronger. Okay, thank you for watching. Bye.